Hello friends, in this video we will see the new concept of the fluid mechanics is Pascal law. So just for the example point of view, I have chosen one fluid element inside the fluid. Fluid is in static condition, so that means what? The fluid is not in motion. Now I have chosen the three direction. This is x direction, y direction and z direction. And here we can see in all the three directions, this is x, y and z. So now here in the direction of x, the dimension of the fluid element is dx. In the direction of y, the dimension of the fluid element is dy. And this is ds. So now we'll see the pressure components in all the three directions. So Px is the pressure components in x direction, Py is the pressure component in the y direction, and Pz, this is a pressure component in your z direction. Now just for the simplification point of view, we have chosen the width of this fluid element is 1. So now we'll find out pressure force on the each face. So the pressure force on the face AB, this is nothing but this is pressure in the direction of x into its area. So the pressure in the direction of x is a Px and the area is dy into 1. Similarly, we can write down the expression of the pressure force in the rest two faces. So the force on the face AC, this is a Py into dx into 1, and the force on this face, this is your Pz into ds into 1. Whatever be the fluid elements we have, that fluid elements have its own mass. So here we have to first calculate what is the weight of this fluid element. So for that we have to write down the expression. The weight of the fluid element is nothing but this is a mass of the element into g. Change the mass of the elements is the volume into density into g. The volume is nothing but here we will find out this is the area of this rectangle. So this is half into base into its perpendicular distance into rho into g. So now after then we will resolve all the forces in the x direction. So here one force is working in x direction, this is your Px. Another in a direction of x, the component of Pz will work. So here we will find out how much intensity of the Pz will work in the direction of x. So here this is Pz and this is the 90 minus theta. So here this is Pz cos 90 minus theta and this is Pz sin 90 minus theta. So here we can see this Pz sin 90 minus theta force is applicable in the opposite direction of pressure force. So now we can write down the equation that Px into dy into 1 minus Pz ds into 1 into sin 90 minus theta, that is equal to 0. That means what? The net force is equal to 0 in the direction of x here. So because the fluid is not in motion, so that net force should be 0 in x direction. So now here we'll find out the value of this cos theta. So for that here we can see this is your theta. So and this is dy and this is your dx. So from here if we'll find out the cos theta value, write the expression. So ds cos theta, that is equal to AB and this AB is equal to dy. So when I resolve this ds in the direction of x and y, then ds cos theta is equal to AB and this AB is equal to dy. So from here we can see this ds cos theta is given. So ds cos theta directly we can write down the dy. So Px into dy into 1 minus Pz into dy into 1, that's equal to 0. From the both sides, this dy and dy will cancel out. So we have the final expression is Px is equal to Pz. Similarly, we will resolve the forces in the y direction. So in the y direction, the forces are Px into dx. So in the direction of y, this is a P by into dx into 1 minus in the direction of y, the component of your Pz. So this is your Pz into ds into cos 90 minus theta minus in the direction of y, the gravitational forces also work on it, dx into dy upon 2 into 1 into rho into g. So now again we'll solve it. So cos 90 minus theta is changed into the sin theta and from here we'll see what is the ds sine theta. So this ds sine theta is nothing but this is a dx. If I resolve again the ds, so ds is this is d cos theta and this is a d sine theta. So now I'll just put this value of dx here. So py into dx minus pz into dx is equal to 0. So from here we'll see the mass of the fluid element is very small, so that's why we'll neglect this force here. So the rest equation is px into dx minus pz into dx is equal to 0. So again this cancel out the dx to dx. So from here we'll find out py is equal to pz. So if I combine both these two expressions, so px is equal to pz and pz is equal to py. So finally we can say px is equal to py is equal to pz. From these expressions, we can conclude that when the fluid is in static condition or the fluid is not in motion, then in this case, at any points, the intensity of the pressure is same in all the directions. Thank you friends. I hope you have cleared the concept of Pascal law. If you like it, then please share and subscribe with your friends.